Welcome to a deep dive
Oh, cool.
into the world of Darmstadtium.
Okay.
It's element number 110 on the periodic table.
Wow.
And it's a synthetic element, so it's not found in nature.
Right.
It's made in a lab.
Interesting.
And one of the really interesting things about it is that it doesn't stick around very long.
Yeah.
So how do you even study something like that?
Well, that's a great question. And that's what's so captivating about Darmstadtium is
Yeah.
it's this quest into the unknown, really.
Okay.
We're really pushing the boundaries of what we know about matter and the universe.
And it's not like they just snapped their fingers and
Oh, no.
poof, Darmstadtium.
No,
Right.
no. It took a long time to make this.
Yeah.
The first confirmed synthesis wasn't until November 9th, 1994.
Wow.
At the GSI Helmholtz Center for Heavy Ion Research in Germany.
Okay.
Imagine fusing two atoms together
Yeah.
at incredible speeds, almost the speed of light.
Yeah.
It's a phenomenal feat.
Like a billiards game, but with atoms.
Yeah.
Correct.
Yeah.
That's a good analogy.
And more energy.
Yeah. A lot more energy.
And it wasn't just this one team
Oh, no.
trying to create it.
No, there were research groups from Russia, the U.S.,
Right.
all pursuing this element.
Wow. So competition
Oh, yeah.
to make it.
Big time?
Wow. So there was drama in the scientific community.
Absolutely.
Imagine the pressure, years of work.
Total.
Reputations on the line.
Yeah.
And then it might only exist for a few seconds.
And it disappears.
Oh, right.
That's crazy.
So yeah, it really highlights the dedication, the competition
Right.
that drives scientific discovery.
And speaking of fleeting existence, you said it exists for just a few seconds.
Well, the most stable isotope,
Okay.
Darmstadtium-281,
Okay.
it has a half-life of about 14 seconds,
Okay.
which means if you had a gram of it,
Uh-huh.
in less than 15 seconds, half of it would be gone,
Wow.
decayed into other elements.
So if you blink, you miss it.
Yeah, you miss it.
So how do you study that?
It's a huge challenge, right?
Yeah.
But scientists have come up with really clever techniques
Okay.
and theoretical models
Uh-huh.
to probe its mysteries.
So they can't really observe it directly?
Not many of the properties,
Okay.
but they can predict them based on its position on the periodic table
Yeah.
and by comparing it to its lighter relatives.
It's like you have a family photo, but one person is missing.
Yeah,
And you're trying to guess what they look like
that's a really good analogy.
based on everybody else.
Yeah, and those predictions paint a very interesting picture.
Okay.
For example, we think its density
Yeah.
is about 26 or 27 grams per cubic centimeter. Now, to put that into perspective,
Okay.
if you could hold a teaspoonful of Darmstadtium,
Yeah.
it would weigh about as much as a bowling ball.
Wow, that's dense.
Very dense.
Okay.
It's also predicted to have a different crystal structure than its lighter relatives, and it probably exhibits properties of what we call a noble metal,
Okay.
which means it's not very reactive.
So it's unstable but also tough?
It is a paradox.
Yeah.
Incredibly unstable,
Uh-huh.
but potentially very durable.
Interesting.
And that's what makes it so interesting to study.
And this is where we get to the idea of the island of stability.
Have you heard of this?
I have, but it sounds kind of science fiction-y.
Yeah.
What is this island?
Well, it's not a real physical island.
Okay.
It's a theoretical region on the chart of Euclid's
Uh-huh.
where some super heavy elements
Yeah.
might defy this trend of just decaying really fast.
Okay.
Instead of lasting for seconds, these elements might exist for years, centuries,
Ah.
even millennia.
So it's like a scientific treasure hunt.
Yeah, it is.
But where does Darmstadtium fit in?
Well, Darmstadtium itself is not stable,
Okay.
but it's a stepping stone towards this island.
Okay.
Calculations suggest that a certain isotope of Darmstadtium,
Yeah.
Darmstadtium-294, with a magic number of neutrons,
Yeah.
could have a half-life on the order of 311 years.
Wow. That changes what we think of as fleeting.
It does.
311 years.
Yeah,
And this is all theoretical, right?
that's correct.
We haven't actually seen this
Oh.
this isotope.
But the possibility is exciting.
Yeah.
And it's driving researchers to push the limits
Okay.
of what's possible.
So before we get to the island of stability
Sure.
and all the potential of that,
Okay.
I think we should take a little break.
Sounds good.
We've covered a lot about the making of Darmstadtium
Yeah.
and some of its properties,
Uh,
but there's a lot more to explore.
totally.
So stay tuned.
All right.
We're going to dive even deeper
Okay.
into Darmstadtium in the next segment.
Looking forward to it.
Yeah.
It's pretty amazing that we can even think about these elements, right?
Yeah.
These super heavy elements that might be stable.
Uh-huh.
It really shows how far we've come
Yeah.
in our understanding of physics.
So you were about to tell us about this island of stability.
Yeah.
What could the impact of this be?
It's pretty mind-blowing.
Right.
Like, imagine a spacecraft made out of some kind of alloy with Darmstadtium in it.
Okay.
That could, like, withstand the radiation of space.
So it would be, like, indestructible.
Yeah, basically.
Wow, that would revolutionize space travel.
Exactly.
No more worrying about all that shielding.
Yeah.
We could go anywhere.
Pretty much.
Wow, it's not just space travel, right?
No. Like, what about nuclear reactors that could power a city for, like, hundreds of years?
On a tiny amount of fuel.
Yeah.
And what about medical implants?
Oh, yeah.
That would never wear out.
Totally.
So this island is a big deal.
It is a big deal.
But how do we even know anything about Darmstadtium if it disappears so fast?
Well, that's where scientists get really clever.
Okay.
We can't observe it directly.
Right.
But we can predict its properties based on where it is on the periodic table and using theoretical calculations.
So like detective work, but with atoms.
Yeah, kinda.
And what does the periodic table tell us?
Well, it's right below platinum.
Okay.
So we think it's probably a transition metal and that it might share some characteristics with its neighbors.
So like platinum, it might be shiny, corrosion resistant, unreactive.
Exactly.
So it's chemically tough.
Yeah, we think so.
Even though it's unstable.
It's a real paradox.
Yeah.
But that's what makes it so interesting.
It makes you wonder what kind of compounds you could make with it.
Well, there's one we think we could maybe study.
Okay.
Darmstadtium hexafluoride.
Okay.
Which is similar to platinum hexafluoride.
Like, why is that important?
Well, it's volatile.
Okay.
Which means it turns into a gas easily.
Right.
And that makes it easier to work with.
So we could learn a lot.
Yeah, a whole lot.
About Darmstadtium.
Exactly.
If we could make this compound.
Right.
It'd be like a gold mine of information.
Absolutely.
So this has been a really interesting journey so far.
It has.
What are some key takeaways about Darmstadtium?
I think the main thing is even though it's fleeting, it can teach us a lot about the universe.
It's like a reminder that there are amazing things to discover.
Everywhere.
Even in the smallest things.
Even in the tiniest things.
And the island of stability shows us that basic science can lead to huge change.
It's all about asking questions.
It is.
Being curious. Yeah. And we've learned a lot about Darmstadtium.
We have.
But there's one thing we haven't talked about yet.
Oh, what's that?
How it got its name.
Oh, yes.
The name.
Naming an element is a big deal.
Yeah.
In science.
And I bet there's a good story there.
Oh, there is.
Okay, so let's get into that.
Okay.
In the final segment.
Sounds good.
So we've talked about how Darmstadtium is made.
Right.
And what its properties are.
And even this crazy island of stability.
It is pretty wild.
But how did it get its name?
Yeah, naming an element.
Yeah.
Kind of a big deal.
Yeah, I bet there's some stories there.
Oh, yeah, there are.
Like rivalries and stuff?
Well, it wasn't that dramatic.
Okay.
For Darmstadtium, at least.
Okay.
But there were definitely options.
Okay.
The team that made it first at the GSI, they wanted to call it Wixausium.
Wixausium.
Yeah.
What's that?
It's a suburb of Darmstadt.
Oh, okay.
Where the GSI is located.
Wixausium.
Yeah.
It's got a ring to it.
Yeah, it does.
But I think Darmstadtium sounds better.
It just fits on the periodic table.
Like he was meant to be there.
Exactly.
Well, what if another team had made it first?
Oh, that's a good question.
Like what would we be calling it?
Well, the American team, they wanted to call it Hahnium.
Hahnium.
Yeah. Okay. After Otto Hahn, who studied radioactivity.
Yeah.
And the Russian team, they like Becquerelium.
Becquerelium?
Yeah. After Henri Becquerel, who discovered radioactivity.
So many options.
All right.
But in the end, it was the GSI team.
That's right.
That got to name.
They got the credit.
So Darmstadtium it is.
Darmstadtium it is.
Officially. Yeah, it's amazing to think that one element could have had all these different names.
It really is.
It shows you how much history is packed into the periodic table.
And international collaboration.
Yeah, it's not just a chart.
No.
It's a story.
A discovery. And for Darmstadtium, the story's not over yet.
Right, we're still learning about it.
Totally.
And who knows what we'll find with the island of stability.
Exciting times.
So to wrap things up, what's the one thing you want listeners to remember?
Even the most fleeting elements can have a big impact on how we understand the universe.
It's like you said earlier. There are amazing things to discover everywhere.
Absolutely.
Even in the tiniest things.
And those discoveries can change the world.
So keep exploring, everyone.
Yes.
Keep asking questions.
Keep that curiosity going.
And we'll see you next time.
Sounds good.